Hello, everyone. Thanks for joining the September office hours. I'm Chris Porter. I'm the Director of Solutions Engineering at StackRox, and I'll be moderating today's office hours. I have with me today Lien Dang joining me. He's our co-founder and the Chief Strategist at StackRox. If you haven't joined one of our office hours webinars before, welcome. Thank you for joining us. These work a little bit differently than other webinars. These are not going to be just a presentation. There's going to be Q&A, and we'll talk a little bit about that. This month, our topic is going to be on mitigating Kubernetes attacks. The Mitigating Kubernetes Attacks is a series of articles and webinars. If you look in the interface, you'll see in the lower left a set of resources that you can link to some of that subject matter. Before we get started, and before I let Wei introduce himself, we're going to go over just how this works a little bit. The lines are muted. The session's being recorded, though, so you'll have an option to get the on-demand recording. We'll send out a link to everyone post-event. Because this is office hours, we're really just going to be answering questions live from you in the audience. Because the lines are muted, you'll have to put your questions in the Q&A module on the right-hand side of the screen. So, any relevant Kubernetes topics, security, cloud, hit us up, get those questions in there. And if we don't get to all those questions in today's session, we will make sure to reach out via email. We will make sure that your questions get answered. We have at times seen people with some trouble with the webinar console. Usually a browser refresh will fix that. So give that a try if you can't hear, if you're missing some of the video. And then we'll get started here. Before we do anything else, I want to start with a poll question. So we asked this on all of our webinars. If you've joined us before, you'll see that some of these questions look familiar. But the first question we're going to ask is really, are you running Kubernetes in production? Meaning you have a Kubernetes environment where you're running applications that are considered to be production. We ask these poll questions because they're really helpful to see the history, gauge our audience a little bit. So the question should be coming up on your screen here. And we'll give everybody a few seconds to answer that. So are you running Kubernetes in production today? I've been really surprised to see how the progress of this over the last few months, the answers here has been progressing. We'll have a couple more poll questions for you. This one should be pretty simple. So I'll give everybody just 5 more seconds to answer this. All right, and here's our results. So 64% of you said yes. That's great. I mean, when we started this a few months ago, generally the answer was less than 50-50. So most teams not running that in production today. Anyway, let's get started with some questions. Wei, thanks for joining me. I want you to introduce yourself here, and then we'll get started. I'll start peppering you with questions here.
Well, thanks, Chris, and hey everyone, and thanks folks for joining us this afternoon. My name's Lien Dang, co-founder and chief strategy officer at StackRox. I work on a number of different initiatives, and including our most recent one, which is writing about Kubernetes attacks, specifically the Kubernetes attack matrix. You should see pointers to resources that we've made available for that in different formats. And I work closely with Chris and the rest of the team here at StackRox to advance the state of Kubernetes security today.
Great. So let's get started with some questions. And this one's actually going to be one that we get quite a bit. So I think we'll jump on this one right away. So we talk a lot about Kubernetes, and your series of articles really addresses the ins and outs of the Kubernetes infrastructure, applications running on them, and all of that security. Now, from experience, I know that most of our customers and prospective customers run Kubernetes on one of the cloud platforms. Maybe it's Azure Kubernetes Service, it could be Amazon EKS or Google, or even a platform provider like Red Hat or Rancher or something. And security is a part of those offerings. So the question really is, do I have what I need? Don't the cloud providers do the security that I need to mitigate attacks against Kubernetes applications?
Yeah, it's a great question, and we do hear it from a lot of customers because a lot of folks are running Kubernetes in the cloud and taking advantage of cloud provider Kubernetes offerings. These are things like EKS and GKE and AKS, and there are huge benefits to going with a cloud provider for Kubernetes. Among them, security benefits. I think the right way to sort of approach how cloud provider can benefit you from a security standpoint with Kubernetes is, part of the broader shared responsibility model. Cloud providers are going to help, operationalize and manage and administer various components throughout the Kubernetes cluster. They're going to help with the control plane components. They're going to help lock down node components in the sense that, many of them offer, hardened container specific operating systems. And so all of those things have, benefits from the standpoint of security. They're going to help patch and upgrade versions. That's one of the starting points for maintaining solid Kubernetes security. We've seen, various types of Kubernetes vulnerabilities being exposed, that can be addressed through, upgrading versions or various patches. And so you'll definitely get those benefits from the cloud provider. And yet at the same time, there's still a lot of controls and settings that, that are primarily set default that, maybe insecure, which may need to be configured, to meet your requirements. A good example of this is, API server is typically, can have public IP addresses that make it exposed, to the internet. There are different, IAM settings, typically through the cloud provider you'll want to think about to configure authentication. It's left up to you to specify, authorized permissions with things like role-based access control. You need to ensure that your applications are utilizing ideally, mutual TLS, for traffic. And so, I don't think it's sufficient to leave it to the cloud provider for all aspects of security. However, I do think that cloud provider offerings can really help with security and provide a very good starting point, to think about your overall Kubernetes security strategy and security program. But, Chris,
Great.
You have a lot of experience working with the cloud providers directly too. I don't know if you have any thoughts here.
Yeah, no, I think what you described there fits in perfectly with that shared responsibility model. Amazon talks about these terminology, and that's where I have some of my certifications. They talk about security of the cloud and security in the cloud. And I feel like there's an analogy there to security of the cluster and security in the cluster, right? That with Kubernetes, you have responsibility for both of those aspects. You are running new infrastructure, and the cloud providers provide tools. Some of the simple recommendations we make, like not exposing your cluster's, API endpoints on the internet, but they're not going to be enforced. They're not going to be something that you're going to get by default. And with a lot of the cloud providers leaning towards I feel like they lean a little bit too much towards convenience, right? Things are done in a convenient way that makes it easy to get started, rather than the more secure option. So jumping in, folks, if you have questions for us on this subject or anything else related, we are here to answer those questions for you, and you can pop those into the Q&A section there, and we'll drop that into the discussion here. One of the first questions that come up is about StackRox, and actually about what platforms we support. And StackRox supports Kubernetes. So all of the cloud flavors, anything that you might run on premise that is standardish Kubernetes, even platforms like Red Hat OpenShift, which is Kubernetes by another name, are platforms that we support for the security software that provides some of the capabilities that we address here. There's always more information about what we do and what our company does on StackRox.com, and we'd urge you to go check it out. And if there's anything of interest here today that you think you'd want to go deeper on, we're happy to schedule some live time with you, and maybe me on the phone. So if you have any questions, we'd love to hear them. I do have some other things that we've heard pretty commonly in the past, and this is kind of relevant. You've been working on this Kubernetes attack framework, right? So how does that relate to the MITRE attack framework, and where does this come from? Like, what's the goal behind this project, do you think?
Yeah, it's a good question, and the attack matrix. The Kubernetes attack matrix, is worth keeping in mind, is based on the MITRE attack framework. And, MITRE attack framework provides this very relevant, well-known basis, for thinking about different types of attacks and how they can be categorized. And so if you think about in that context, the attack matrix is really an extension of some of the principles that underlie the MITRE framework, which is you have different types of attacker techniques, which are really more about the how an attacker might go about taking specific actions. They reflect specific methodologies that are at an attacker's disposal in a given environment, in this case, Kubernetes. And then they're categorized on the basis of what an attacker is trying to accomplish. And so those are categories called tactics. And so the Kube attack matrix is made up of 9 tactics and 40 individual techniques within those 9 tactics. And there is overlap. There are different techniques that can be utilized to achieve different objectives. But I think what the framework provides is this almost like knowledge base or way to better understand what are the things an attacker might try to do, and then how specifically might they try to accomplish them. And there are other attack matrices that exist. There's attack matrix for enterprise. There are different types of platforms, but sort of taking this consistent approach to how we think about different types of threat vectors. And that's very powerful because it allows you to think more holistically, particularly with respect to the tactics, holistically and more comprehensively about how you might deal with different types of threats. And the reason for that is, you often see, different types of incidents or security issues that are publicly disclosed, or you see them in the media. And, while those are worthwhile to help you understand, what could go wrong, or how we could, what we might better need to protect against, we don't want to treat those as sort of a one-off or deal with them in an ad hoc manner. You want to make sure that you're dealing with them systematically, that you're thinking about how these might relate to other similar types of attacks. And address those all at once. And that's what sort of the attack matrix and attack framework allow us to do.
That's really great. One of, some of the follow-on questions from that would be that in your guidance, some of the articles you talked about using, Kubernetes native controls, like ways that are sort of, become available in this build, deploy, runtime kind of model to mitigate some of these attacks, things that wouldn't be available in traditional infrastructure. Can you give an example, maybe something that would be like a Kubernetes native control that I can use to defend my applications?
Certainly, there's several. I'll highlight just a few today. But I think one of the great things that the Kubernetes community has done and undertaken is to think about how as a modern infrastructure platform, security can be better incorporated, and how we can better address security problems through controls and capabilities that are available and built into Kubernetes itself. And so, of course, there are a wide range of different security problems you might look at. Looking at a Kubernetes environment, you might focus on the cluster level, you might focus on individual pod level. And so a couple of the capabilities, that can really have high value impact on your security posture that are available in Kubernetes to be configured. These are things like, role-based access control, which, allow you to, set permissions and privileges on what users and, applications can do. There's network policies, which, allow you to segment your network, including pod-to-pod traffic. There are pod security policies, which allow you to configure settings and harden pods and containers at a more granular level. There's secrets built into Kubernetes, which is really about allowing you to utilize sensitive data and credentials for your applications. And so all of these are very rich capabilities that can be taken advantage of and leveraged to implement security best practices and security that meets your organization's needs. And I'll also say that that provides a starting point for what we think of as Kubernetes native security, which is leveraging these controls, but also focusing around the end user experience, security user experience, and ensuring that you're focused on things like Kubernetes native objects, Kubernetes artifacts, Kubernetes metadata, and so on.
Great. Yeah, I've been surprised the number of assessment environments we get into where not only are they not aware that Kubernetes has an RBAC subsystem, but sure enough, every developer in the organization is using a cluster admin level of access to manipulate objects and run applications. And that's a quick path to a privilege escalation, and it risks not just your app, but every application running on the same cluster. So keep an eye out for RBAC. So we don't have too many questions, folks. If you're listening in and you have a question you want to answer, you would like a discussion that should go down, by all means, get those into the Q&A section there. In the meantime, I'm going to pause for a second and ask another poll question of the audience here, and ask about container security and if this is an active project. By the nature of the topic today, I'm assuming that you have an interest in security if you've joined us here. And so we want to ask, what the timeline is. We're trying to gauge whether or not teams have thought about security up front, if this is something that you're going to apply to an existing environment. Give us an idea of what your timeframes are. We'll give everybody a few more seconds. And then we'll show the results. So, all right, we'll do the poll results. All right, less than 3 months. That's great. Over time, these polls have trended towards more Kubernetes production use, more of an awareness and a concern about security. All good stuff. Thank you, everyone. So we do have some question here actually from Nick about secrets actually, and what are the pros and cons of using the Kubernetes native secrets injections versus something commercial like a HashiCorp Vault to distribute those secrets?
Yeah, I mean, I think one of the biggest advantages, of course, is that it's built into Kubernetes. Operationally, it's going to be, a lot simpler and easier. I think there's those operational considerations. I would say over time, Kubernetes itself has taken steps to better protect, secrets and made advancements there. For instance, you can encrypt secrets now in etcd. And so on. I think where, and Chris might have an opinion here, but I think where we see customers looking at, maybe external secret stores like, HashiCorp Vault and so on is really when you want to think about, secrets, not just for, containers in Kubernetes. You might be thinking about how you want to manage that type of data and credentials for, other environments too. And so it provides a more unified secrets management solution. But I think if you're focused on Kubernetes, there are a lot of benefits to going with Kubernetes secrets itself. But Chris, I don't know if you have a perspective on that as well.
Yeah, we typically recommend that using the built-in Kubernetes features are the right way to go, right? It's built in, it's access controlled by namespaces. Like there's a lot of advantages to it, and it's scalable to the level that Kubernetes is. So it provides a means of distributing things. But I'm careful to note that if a customer's already established, like you said, with a cloud provider solution or Vault, that there's that level of integration can still be supported in that way. And if you're using more than just Kubernetes, you probably do need to look at a solution like that. Or if you have specialized security requirements, which you and I are familiar with, if your secrets have to be backed by HSM, you need to get in and have a service that can have that kind of hardware backing the secret store. So yeah, there's good reason to use those third-party products. We would certainly recommend something that works with Kubernetes, right? We want to make sure that that you're still thinking about the platform as being in charge of everything here. Okay, we have some more questions coming in, so folks are warming up. Go ahead, Ray.
Just one thing to mention is I do think operational complexity should not be overlooked. That there is more complexity to sometimes running third-party solutions, and so those considerations should just be weighed alongside, what you're trying to accomplish. I don't think there's no right or wrong answer here. I think that it's kind of what comes down to best suit your needs. But I think there are benefits and trade-offs on both sides.
Great. The next question is similar, but a little bit of a different subject, about registries that we might recommend. Do we recommend a particular registry like, Harbor or Notary? And do those tools help in security? Is that something that teams should think about as far as this goes?
Yeah, that's a great question. I think first, it partly depends, I think, on what environment you're running in. We see a lot of organizations who are running in cloud, for instance, using cloud provider registries. This is like, Amazon Elastic Container Registry or Google Container Registry and so on. Some of the ones you mentioned, like Harbor, those would be standalone. So it partly depends on what environment you're running in. I think each of them has different security implications. Some registries have image scanning as an example built in, and so you can scan for vulnerabilities that exist in images stored in those registries easily. Google Container Registry has Google Container Analysis, which is a good just one example of that. Amazon ECR also has scanning available, and so there are aspects that will help with security. I think one thing that is probably key is you want to set up ensure that you have private repositories. And then separately, we still do see a lot of organizations and users pulling from public registries like Docker Hub, and when you're doing that, you do need to ensure that specific security policies are set in place. Perhaps access policies as well, because you may pull something inadvertently. Or otherwise, and there are examples of, for instance, backdoored images existing on Docker Hub, or those types of things leading to other security issues. But also, I just want to point out, since you asked about Notary, Notary is not actually a registry. That is a project that will enable image signing, which is also a separate, maybe requirement for some folks, or a use case that you're looking to address if you want additional or sort of enhanced image assurance around your images that you're deploying after they're built. And so that might be another consideration alongside the registry. But I think there are a lot of registry options out there. I think the key factors to keep in mind are ensuring that your images are private and managed and can be accessed securely, and then separate from that, some of the operational considerations of whether you want to run your own registry or utilize one that's managed for you, like what a cloud provider would do. And then third, whether you care about image scanning being built into that registry or not, or if you're going to run a standalone image scanning solution.
Right. Yeah. So it's back to that topic we often talk about here at StackRox about controlling your software supply chain. Where the library is coming from, where's the images coming from. Like, these are artifacts, these components that you're getting, and if they're coming from an outside source, you have that risk of them potentially being compromised or at least incomplete, right? And so potentially jeopardizing your application there. I would say that it is one of the top recommendations that we make is restricting the registries that your Kubernetes clusters can use, either to a local cloud provider. So it's not about which product you choose, but about restricting things appropriately. Some teams chafe at that a little bit because they love pulling from Docker Hub and having that flexibility. As Wei said, putting some additional controls around that sort of unknown stuff is probably the best recommendation that we can make. So we've got a few more questions coming in here. I'm not sure that we can address all of them here. Alex asked about OPA, and we're familiar with this, and it's been a pretty good. There's been quite a few questions about it. Can you give us a little bit of background on what OPA does, like how StackRox compares, what our thoughts are on Open Policy Agent?
Yeah, so OPA is I think a very exciting project. It's actually I would say gained substantial attention and traction within the community. It's just recently actually applied for CNCF graduation, which I think reflects that interest and attention. I think the way to think of what OPA really is it provides a broader, more extensible way of thinking about policy management and policy enforcement for modern applications. Beyond just Kubernetes specifically, though I think there are a lot of tie-ins in ways that the community is thinking about incorporating OPA into Kubernetes to enable certain types of functionality. The most I think probably one of the areas that has gotten the most attention for where OPA can help Kubernetes is there's been a lot of discussion around something like OPA Gatekeeper, succeeding or taking over pod security policies as an example. And there actually have been platforms like Azure Kubernetes Service that have moved to enable that type of work and that type of functionality using OPA Gatekeeper. But I think at the same time, the use cases for OPA and such are still being established. I think we see a lot of people using it for things related to configuration management and so on. Things like admission control can benefit from OPA. And for StackRox, I'll let Chris share his perspective on this. But for StackRox, we have a lot of similar and shared views on the importance of policy enforcement in these cloud native environments. And so we've also undertaken a lot of work that in the future could benefit or even amplify the work that the OPA project makes available, because we have a rich set of 70 plus built-in policies and a way of applying policies across the full life cycle that also are unique in terms of how they benefit security. But I'll let Chris sort of maybe touch on how we think about policy enforcement, because I think a lot of that aligns with the general OPA intent and philosophy behind OPA.
Yeah, and then there's some follow-on questions here that have come in from OPA. So clearly this is a pretty hot topic. And, with OPA, our customers generally have been looking at it as a way of looking at that particular silo, right? The subject matters that OPA covers are kind of limited to that deployment area. And our philosophy really is that a lot of the things that you want to measure, like as a security or a compliance business goal, are going to be in more than one silo, right? It's not just about what went into the image contents, but how it's being deployed. And so our engine here is really designed to allow you to understand, like, for example, when you have vulnerabilities in a privileged container, right? That combination of things, which is an attribute of a deployment and an attribute of an image, combined in one policy, so you can get a little bit more of that signal out of the noise. Things like runtime, right, which aren't covered by OPA at all, are a challenge because there's a lot of potential noise here. And most of the systems that would measure, how I'm running containers in my environment don't take into account the namespace that it's running in, or whether this is a development or a production cluster. So that context is what we focused on, right? So we don't use OPA for that part of it. And that allows us to combine the attributes there. And there's a lot of built-in examples of policies in the StackRox product that invoke some of the controls that we've talked about today. And they span that life cycle. The other is that, OPA is kind of frustrating in that it provides you with the feedback as to what happened, like what the problem is. And that's good. That's rule number one, I think, of a security tool. Don't be a black hole of enforcement that just says failed and provides no feedback. So OPA can tell you what attribute it was that failed, but there's nothing any more rich about it than that. And we're trying to make sure that when this gets back to the dev team, they understand clearly what's required, where the gap is, and what they have to do. So again, our policies are written in a way not just to detect that initial condition, but to make sure that the right team has the right information to resolve that going forward. And so we have customers that are using this today with OPA, and OPA fills a portion of that, and then StackRox fills the security use cases that are part of this as well. So in fact, we started to cover some of these other questions here. How we talked about the Kubernetes attack and the attack matrix, and Nawab is asking us, can we talk about how StackRox can help identify and protect some of those? Like, do we have features specifically to address some of those, the attack techniques that you mentioned?
Yeah, so there's a lot of different attack vectors, right? There's 40 individual techniques, and for details of those, in a breakdown of those different threat vectors and how to mitigate them comprehensively. We have other resources like a series of blog posts as well as a white paper on the topic. We also have a recorded webinar from a couple weeks ago where we touched on those things. I think the takeaway, however, from the matrix overall is that there are a wide range of different types of threat vectors that you need to think about, but the mitigations can also be common to several, which is to say 40 different threat vectors doesn't necessarily mean you need 40 different ways or 40 different mitigations to protect yourself. There are actually a number of a few controls that have high value which can be used to protect against many of them. And so that's even separate from StackRox. And so I would say take a more complex attack vector in the matrix as an example, one that leverages an application vulnerability. In this case, there was a technique that references a remote code execution vulnerability, and so there's actually a wide range of different controls that you're going to, or mitigations that you're going to want to take. You're going to want to ensure that you're scanning for vulnerabilities in your images in Kubernetes itself. You're going to want to segment your network so that if there's a compromise on a particular pod, that you're going to limit the blast radius of where a potential threat actor can go. You're going to want to harden your pods in the sense that you're going to limit its privileges. You're going to limit what that particular service account that is bound to the pod can do to further limit and scope down what would happen if there was an actual compromise. And so I think those types of principles which apply to that particular technique, it can be thought of, throughout, many of the other threat vectors that are represented. But in terms of how StackRox helps, in two regards: one, where native controls can benefit you or protect you from these different attack vectors. StackRox helps takes the complexity out of managing and configuring those native controls. And then in the second, StackRox complements all of those approaches with things like runtime monitoring and observing and detecting system level activity that reflects particular techniques that that are outlined in the attack matrix. But Chris, I don't know if you want to elaborate on the ways that StackRox addresses some of the threats in the attack matrix, but we cover more than 75% of the different techniques directly in the StackRox platform.
Yeah, my favorite example of this is, and when we have this as a demo, in fact, we'll point you to some resources. If you want to see the StackRox product and some of these attacks live, some of our product managers have delivered these things on recordings and webinars. I talk about them in some of the sessions that I do about handling Kate security. One of my favorites is the use of the read-only root file system, right? We've seen that an entire class of attacks that require putting a payload to disk, right, or modifying the configuration of the container, effectively can't start, right? We have a demo about with the struts vulnerability, and I know everybody uses this. It's a little long in the tooth, I guess, but the struts vulnerability for 2017 is still one of the top 10 exploited paths. Get your containers application to run arbitrary commands, and then install software and run a crypto miner. And it's great to see how, the very first step, right, downloading a payload onto the container can fail. And so what StackRox is there to provide, of course, is the understanding where that gap exists and help your teams understand that, this is a preventive mechanism. And especially in services that are going to be directly connected, let's say, to the internet, that having the read-only root file system on those containers enforces that immutable nature of the infrastructure. And just makes these attacks fundamentally impossible. It's cool stuff to watch. We have a few other questions coming in here. So back to secrets management. Do we have plans, or can we monitor on configurations of non-Kubernetes secrets managers? This one today, I know that we don't today have any plans for this. Partly because we've got a lot to do with Kubernetes, and Kubernetes secrets are generally the mechanism by which those integrations happen, even if the storage and the source of it is externally. I don't know if you have any product thoughts on that one, Wei.
I think generally, our overall philosophy is that there's a rich ecosystem of cloud native tooling around there. Secrets management solutions are one subset of that. And so our general approach is to, want to integrate with, tool chains and tooling that organizations have. I do think we see a lot of organizations utilizing Kubernetes native secrets, similar to, but we have the same philosophy that extends to things like image scanners, as well as, SIEM and incident response systems. And so generally, our view is, we like to integrate with the set of tooling that the ecosystem is out there. I just think that we do see relatively fewer people utilizing these third-party secret solutions. But as I spoke about earlier, when the question came up, there are very valid reasons, to consider a solution like that if it suits your organization's needs. But in terms of how it fits into your environment, I think it's just worth mentioning generally that any additional components and tooling will introduce some operational overhead. Could also introduce different points of vulnerability from a security standpoint. So always worth keeping in mind.
Great. So back to OPA, there's some questions about whether we're going to be integrating OPA directly into StackRox, and so that policy and OPA can be worked on from within StackRox. I'll start off by saying that with working with customers who've been using OPA, what we've done is actually incorporated some of the capabilities that OPA has into our policy engine. So again, we're a multi-stage, criteria company here. Like the policies that we've written to accomplish some things like isolation of pods and deployments, or the intrusion detection that we do, run across those different lifecycle stages. And so the goal has not been to just duplicate what OPA has done, but provide a better version of that. Also managing OPA is a separate product inside of the cluster. And again, if we can meet the use cases that OPA is meeting for you today in the product, we think that the broader integration in terms of multi-stage lifecycle policies, the education, the empowerment for developers, compliance reporting, notifications, we think that that's a better way to approach this. So if there's something that we didn't do today, some value from a deployment that we don't currently query, that's not something that's too hard for us to add into the product, and adding it in our product would give you the benefit that this was all, has all of the additional policy capabilities that we have in the platform here today. So I don't know if you have any thoughts on that.
Yeah, I think the clearest point where we are actively monitoring OPA and thinking through its implications, and I think the community is as a whole, is how OPA might be potentially integrated and taken advantage of and leveraged with regards to Kubernetes capabilities itself. And so when you consider something like how Gatekeeper might be utilized as pod security policies are deprecated, that becomes a natural point for us to consider how that fits in with being Kubernetes native, and then that functionality being a native part of Kubernetes, the Kubernetes platform itself, in terms of enforcing policies at a pod level, at a container level, and so on. And so from our standpoint, some of these developments with regards to OPA are extremely interesting, because it's not really just about thinking about policy enforcement more generally, separate from the Kubernetes platform. It's really thinking about how we can actually integrate this policy enforcement functionality into the system going forward. And I think that's the main issue that the community has been thoughtfully sorting through. And so it's something that we're actively following and looking forward to seeing the outcome of.
Great. I've got a couple of different questions, not secrets and OPA here. So completely different. With containerized applications, which of the various container runtime engines would we recommend? I guess, is there a security consideration around things like Docker versus Cryo or Containerd? Any thoughts there?
Yeah, I mean, I think that, first, I think the general trend in the ecosystem has been towards, standardization and really, standard framework and interface that allows for the development of different, container runtimes and container engines. And, I think that's a great thing because it enables more choice and flexibility for customers. Now, practically, I think, a strong consideration, in my opinion, for how you should consider what container runtime you want to use is dependent on what Kubernetes platform you decide to go with. For example, if you're using Red Hat OpenShift, then Cryo is going to be a natural choice, and that's really what is going to align with and is sensible from a standpoint of what runtime you want to use. I think over time, other platforms will also gravitate towards different default engines that they support. And it's not to say that they I'm sure that everyone's thinking about it being pluggable and offering that choice, but I do think there are benefits to going with sort of the default engine that's going to be supported by a given platform. So historically, that has certainly been Docker, but I think that the community has seen opportunities to, especially for running container runtimes that are a little bit lighter weight in some aspects or don't need all the functionality, for instance, that Docker packages, to move to something like Containerd, for instance. And so if you look at Azure Kubernetes service, they're further along in terms of moving towards Containerd as the default runtime. And so I think that should be a starting point for how you think about what runtime to use. I'm not saying that should be determinative, but it should definitely be a strong consideration because you do want to ensure that the runtime engine you're using is going to be fully supported and by the platform or distribution that you're using.
Great. The next one is another different one here about the Kubernetes dashboard. This is the administrative GUI that's provided with Kubernetes, part of the CNCF. It's part of Kubernetes, but it is often a vulnerable component. So Josephine is asking about security and recommendations that we have for Kubernetes dashboard.
Yeah, I think I actually think an important starting question or valuable starting question with regards to the Kubernetes dashboard is why you might want to enable it. In fact, a lot of the platforms nowadays actually disable it by default or don't deploy it. And StackRox actually has a policy to alert if the dashboard is in fact deployed and running. And the reason for that is historically the dashboard has been a point of vulnerability for cluster compromise. There have been examples out there, and it's actually one of the techniques specifically described in the attack matrix, where as an example, one of the disclosed stories was Tesla was running a Kubernetes environment and was compromised via the Kubernetes dashboard, which allowed attackers to accomplish cryptocurrency mining. And the reason for that is, partly of the way, the settings that were used when the dashboard is sort of like deployed by default. So if for some reason you really need to deploy the dashboard, which we would not recommend, but if you did want to deploy it, then it's really important to ensure that you limit network access to it. A lot of these compromises that involve the dashboards were exposed publicly to the internet. And then separately, you want to ensure that privileges on the dashboard are restricted. A lot of these compromises involved Kubernetes dashboards that had elevated privileges in the sense that role-based access controls were not appropriately configured or so on, which allowed someone to gain privilege and then do more harm within the environment subsequently.
Yep, that's been one of our standing recommendations, and I agree that it's actually generally got a cluster admin service account on that deployment. And that creates a risk because that dashboard really does have the ability to administer the entire environment, including destroy the cluster and access data on other nodes and on the services. So we generally strongly recommend against running it, especially in a production environment. But if you do need it, some of those restrictions that we recommend on a lot of applications would apply here. So thank you for that question. I guess we can't avoid this one because there's a few questions now stacking up here about Istio and general about the service mesh topic in general and ingress controllers. Do we incorporate any of these? Do we recommend any of them? What's our current support? And Istio comes up here a lot, but I suppose that question could be directed at any of the service mesh technologies.
So take the first one in terms to start, which is which ones we integrate and support. Today, as an example, we provide visibility into Istio, including Istio services that are running. And part of that reason why I start with Istio is that Istio is built on Kubernetes. It has dependencies in Kubernetes via custom resource definitions. And so I think it's aligned significantly with sort of the overall direction of Kubernetes. Of course, there are other considerations that may lead you to a different service mesh, but I think one of the key consideration, some of the key considerations worth keeping in mind when you're thinking about service mesh or thinking about the particular use cases you want to accomplish via service meshes typical ones we see are ones related to authorization. And so that's another one where we feel Istio has a very rich framework for authorization. Originally, it started as role-based access control, and so it's morphed something more holistic based on authorization. The other is mutual TLS, so that, traffic encryption, traffic can be more easily encrypted, especially when you're running applications at scale or, in a microservices architecture. And so that's some of our general viewpoints, on service meshes. I think for the purposes of, this session, I'd like to shy away from recommending any particular service mesh technology. But I think that if you look at something like Istio, however, you'll see a lot of alignment with sort of the overall direction of Kubernetes.
Right. And to answer the functionality questions here that are part of that, StackRox works with all of these. We don't have a strong opinion just yet, and that any one is better for security. It's really about what your application requires and what infrastructure features you're looking for. Our product here, the Kubernetes security product, works with all of them, right? That Istio and Linkerd and others are all supported platforms that will work, and we can provide security support in Kubernetes natively there. The next question here is actually a follow-up to our topic about about RBAC and about cluster admin credentials, because I've noticed a few spots where everybody on the user team has cluster admin credentials, and applications like Helm Tiller in V2 and things like Argo CD and even Prometheus will often have cluster admin credentials. So how can we tamp that down? Do we have suggestions, in this case specifically for integrating KubeAuth with external services like Active Directory?
Yeah, I think it is worthwhile to separate out authentication from authorization, right? And RBAC is really about authorization. And some of this will vary depending on the environment. Particularly if you're focused on authentication and you're running in cloud, you're going to look at cloud, identity and access management services. But I think with regards to RBAC, one of the ways that we see people effectively managing, some of this complexity or role management around RBAC is to think about a set of baselines for particular roles, because Kubernetes has a lot of different capabilities that are intended to make RBAC more flexible. There are features like role aggregation. And then also you can easily end up with a lot of overlap in role definition. And so the problem with those things, or so the downsides of those things, if they're not managed appropriately, is it can lead to a lot of complexity. And so you may not, you may inadvertently grant access for a user or service account that you don't intend to. It also becomes difficult if you're looking to deprovision or descope privileges. And so our general recommendation typically is to start with sort of a baseline definition, and then add incrementally from there, so that you better understand kind of the full scope that any given user or service account has. Now, I think you can then take those baseline roles easily and map them to roles assigned via your existing identity management solution, which might LDAP, AD, Cloud IAM, or whatever it might be. But I think that's a more general approach, without knowing the specifics of how you might think about configuring and managing role-based access control. So it can lead to issues, and we've seen it before, where RBAC's a good thing, but it can also get complex very quickly.
Yeah, we have a great webinar and an article on our blog site that covers this topic. It's called Top 5 RBAC Mistakes, and it talks about things like the cluster role aggregation and what happens when you use some of those features and some of the built-in roles that inadvertently grant additional privileges. As far as integrating with external systems in general, the fewer the number of people in your clusters, the better, the fewer individual users. That can be tied into external systems like AD through OpenID Connect. You're probably looking at using like ADFS for that. Some of the best techniques that I've seen have generally restricted the high level of privileges in a cluster to the automation tools. All right, if you're pursuing like a GitOps style workflow and you're using something like Flux or Argo CD, those are the tools that have the credentials in the environment. They're the ones that that are running your cluster, and individual people don't actually have much access to the clusters there. Another topic is building the right rules, and we notice that I've seen this in a lot of open source projects that provide a kube deployment. They'll say, hey, create a service account and grant it cluster admin role. And that's because it's easy to do that, and it makes the product work right and not get those pesky, permission denied. There are some open source tools around this. One of the things that we've looked at, that I've looked at and had some customers playing around with are some tools like, I think it's Audit to RBAC, that actually take a look at your kube audit logs to try to understand, what kind of permissions your users are actually using, so that you can restrict to better RBAC roles, right? Instead of giving them cluster admin, give them read-write to a particular namespace or certain things like Kubernetes events. So the more restrictive you can be, the better. So there is a question here. We are getting to the end of our time, but we'll have a couple more minutes left. For Kubernetes monitoring, so this is a different topic. What do you think about Prometheus or Grafana from a security observability standpoint? Are these tools just reactionary, or can they be proactive?
Yeah, I think it depends on what type of cluster monitoring you're looking to accomplish. First of all, is it more about say like resource and performance monitoring, or is it about security monitoring? Because I think that could definitely lead you down different paths. I think with respect to security monitoring, to start specifically, this type of observability is can be helpful, I would say, but is insufficient. You really need to be looking at system level. You need to implement system level monitoring for activity at a much more granular level, preferably what every single container and pod is executing within the environment. And the reason for that is that any type of anomalous, malicious, or otherwise security relevant activity that's going to happen is going to happen at the level of individual containers, and you want to be able to understand that at a more granular level so that you can diagnose the root cause of that particular security issue or that unexpected behavior. And so that's something that StackRox does. We implement, and I'll let Chris elaborate, but we implement runtime monitoring at a system level. But I would say more broadly for monitoring that's relevant to resources and performance. Generally, I think Prometheus is certainly one that makes sense to consider. It's a CNCF project, and I think generally there's a lot of benefits to aligning with these projects that the community is continuing to support and advance, and a lot of benefits in terms of integration and how it fits in with Kubernetes to consider as well. But I think from a security standpoint, these are certainly not enough. You need to think about how you're going to complement and actually achieve security relevant monitoring at a lower level.
Yeah, it matches my experience with customers in the field. I think the companies that are startups, they're born in the cloud, they're only running Kubernetes, Prometheus and Grafana have been a natural choice. And they're using it for generally observability of performance metrics. But large organizations, I think the choice of tools for that is going to depend more on the kinds of things, existing tooling and existing infrastructure that you might want to incorporate under the same guise there. We have been successful in using some of the capabilities of those tools to, again, to help teams understand what their applications are actually doing, what the behaviors are in a production or a staging environment, and then help to use that to help build the controls to box that in, right? If we know the roughly CPU and memory usage, for example, you can use Kubernetes to restrict that, to provide for memory limits and CPU limits to avoid runaway containers. So anything that you're measuring today, there's an opportunity to help restrict it to avoid that kind of undefined behavior. That also helps to keep your attackers boxed in when you can restrict things in a cloud native, in a Kubernetes native kind of way. So I think we've answered most of the questions here. If we have missed anything, we'll get back to you. We'll reach out to you and try to provide an answer or thoughts on all of these things. We have one last poll, so we're going to put that up on the screen here before we depart and ask you a little bit more about where your security priorities lie. I'd also like to take this opportunity to thank everybody again for joining. And if there's something interesting here that we didn't get to that you'd like a personalized demonstration, feel free to reach out to us as part of our outreach, respond back to us. We're delighted to get you a demo, show you what this can do in your environment, answer your questions. That probably will be me or my team. So you get access to the folks here at StackRox who can fill you in. We also have some other resources that we'll send out. We did see some questions here of things that we've actually got demos for. We've got articles on, and the StackRox blog is a great resource center for that stuff. You'll see things like recommendations around RBAC usage, general recommendations around Kubernetes security, and of course Way's series here on the Kubernetes attack matrix. So we'll push the poll results out, see if it's surprising to anyone. Great. Well, vulnerability management, always the solid base of all of the responses here. Quite a few talking about network segmentation and runtime threat detection. That's great. It's good to see that teams, concerns match ours. In general, the priorities I see here match kind of every one of my customers' priorities and what we're tackling in order. So unless there's any last minute questions here that we could quickly answer, I'm going to thank everybody. We'll draw this to a conclusion. As we mentioned, this will be on a recording, and so you can enjoy the conversation, not so live the next time. We'll also follow up with all of the unanswered questions and some of the resource materials that we've hosted as part of it. Wei, it was a real pleasure. Thanks again.
Thanks, Chris, and thanks everyone again for joining us this afternoon.
Great. Take care, everyone.